It's not always going to be fixed positive. I could give you an example where it's fixed negative, right? It could be. Okay, now what about the bottom? Is it 0? It is 0. Okay, this is 0. You go negative 3 squared, that's 9. 5 times negative 3 is negative 15. So you go 9 minus 15 plus 6, you get 0. Right? So I know right now, at this point in time, I know the answer is either what? Positive infinity or negative infinity, right? Or maybe it doesn't exist. The only time it would maybe not exist is if we didn't have this here. Then we'd have to check both sides. But if it's a one-sided limit, then our answer is either going to be positive infinity or negative infinity. Right? I know that right now. It's one or the other. Okay? So that's where I am in my head, right? In my head, what I'm thinking to myself right now is it's one of these, right? It's either it's that or that. So I have to determine which one it is. So you take out a coin and you flip it, right? No. You have to figure it out. So how are you going to figure it out? You plug in, so you draw a number line, right? You put the point you're approaching, negative 3, and which side are you approaching from? The left side, over here, right? What's the number to the left of negative 3? Negative 4? That's okay. To me, that's not close enough. I mean, personally, I think that's, because it's the limit is approaching negative 3, right? Like you wouldn't want to say like negative 10, right? So go with something like this is where we talked about what's close in this class, right? What does it mean to be close? So I'm going to say negative 4 is too far. So something else. Negative 2 point, careful. Which side of negative 3 are you on? So this is negative 4. I did this intentionally. That's the most common mistake is that people will pick a point over here and say like negative 2.999, something like that. Remember, this is on this side is negative 2.5, 2.75, right? You're getting closer this way. This way it's like negative 3.001, something like that. Right. So that, I need to pick a number like this.
I don't do that in my head.
Yeah, and plug it in here, right?
Yeah.
Okay, well here, how about this? Why don't we do something before we move on? Why don't we take the limit as x goes to negative 3 from the left of x squared plus 9. If I know that negative 3 plugged in here gives me 0, I know it factors. So this becomes x plus 3 times x plus 2, right? That factors that way. And because it factors that way, now I can kind of see what happens. Think about what happens if you take this number, right? This number, and you plug it in here and here. So let's talk about this one. What would happen if you plug in negative 3.001 and then you add 3 to it? What would you get? Positive or negative? Careful. Negative 3.0, right? Negative 3.001 plus 3, right? That'll be negative, because this number is a little bit bigger than that one, and it's negative. So when you add those two, you get negative, don't you? So this is a negative number. All right, what happens when you plug negative 3 into this one? You're about negative 1, right? But that's just a negative number, isn't it? So this is negative as well. What happens when you multiply two negatives together? You get positive. So here's what I can say. This is approaching 0 through positive numbers. So I don't know, you asked, can you just give me an answer, right? I don't know if you would have got I don't know. I don't know if you would have got positive infinity doing whatever you would be doing in your head. I don't know. It's just risky to not analyze what's going on. So your answer is positive infinity. You have two positives. Yes?
Could you explain the last part again, just one more time?
I'm saying what's happening as we approach negative 3 from the left, right? So I just pick kind of a number that I know is close to negative 3 from the left, and I plug it in right here. When I plug it in here, I get a negative number. Do you buy that? If I plug in negative 3.001 plus 2, that's negative as well. Two negatives are going to multiply to be positive, and so I know my denominator is getting small, but it's headed to, it's positive always positive. Got it? Yes?
Why can't you use negative 4, just for curiosity? I know you're changing, basically you're changing your
Okay, because, okay, could you use, what if I had you come in from the other side? Okay, just for the sake of this works out. If I had you come in from the right, maybe you'd want to use -2.
Okay.
Okay, right, maybe?
Maybe.
Okay, you can't plug -2 into this. It's undefined,
Okay.
right? So the thing is, like, you could have a function where -4 is actually going to have, like, something important is happening at -4. And so it can mess up your analysis of things. I mean, look, if you want to go with -4, go with -4,
Okay.
all right?
Yeah.
But just realize that, to me, that's not very close. You risk that maybe there's something going on. What if there was another, something undefined here? Like, what if there was another factor here where you had 0, if you plug this number in, then your analysis is going to be wrong because you aren't close enough to -3. There's too much shit happening in between there. And does that make sense?
Yes, sir.
Yeah. All right, let's do another one. Oh, by the way, what would change if I came in from the other side? Can we do it maybe just mentally without writing it all down? If I came in from the right side instead, right? If I came in from the right, I'd be coming in this way. Then you'd be using -2.99, something like that. Does that change what's happening up top? No, right? Now how about on the bottom? -2.9, if you plug in -2.9 here, what do you get? Oh, you get a positive there. And if you plug in -2.99 here, you get a negative. And when you multiply a positive times a negative, you get negative on the bottom, right? So now this is negative, and positive over negative, you get negative infinity. So you see it's going to change the answer? Yes? I always have students ask me, if it's negative here, like if you're coming in from the left, does that mean your answer is negative infinity? And the answer is no, okay? You always have to analyze it. This right here does not tell you what your answer is. If it were that simple, that's what I would tell you when we start the whole thing, right? Just be like, oh, whichever side you're coming in from, that's what infinity you're going to. I would tell you that. But you have to analyze it, all right? You have to see what's happening. Let's do another one. Limit, let's go x goes to 5. Let's come in from the right side of this. And let's do, x minus x squared over, and down here let's do 5 minus x squared. All right, for all limits, you always just let x go to whatever it's going to, right? So here x is going to 5. So we get 5 minus 25. 5 minus 25 is -20, right? Over, okay? And then 5 minus 5 is 0, right? So this is going to be this scenario. So up top we have a fixed number, right? But it's negative this time, right? It's a fixed negative number. And we're dividing it by a number that's approaching 0, right? It's getting closer and closer to 0. We just don't know, is it going to be approaching 0 through positives, or is it approaching through negatives, right? We don't know. Or do we? We do. What do we, how do we know?
You plug in 5.001, you get a negative number, but you're squaring it, so it's going to be positive.
Yeah, so do I even need a number line? I actually don't need it because see the squared here, that's the big thing. No matter what I do in here, I know this is getting close to 0, right? I don't know if it's positive or negative. I don't know if when I plug in a number here, I'm going to get a positive or a negative. But the fact that I'm squaring it's going to make it irrelevant, right? Because it's going to become positive no matter what. So if I did, let me do the number line anyway. If I came in from 5 from the right-hand side, I could pick a number like 5.001, something like that. If I take 5.001 and plug it in right there, 5 take away 5.001 is a very small negative number, yeah? But then you're squaring it, so it's going to become positive again. Yes? So I know right now it's this right here, I know it's positive. Now if that squared is not there, then I have to actually, think about it and do this. But because the squared is there, I know it's going to be positive on the bottom. So what's our answer? Negative infinity. Yes?
Do you have to go back and plug into the top, or is that?
No, because you already know what happens up top. You already know you're headed to negative 20, and that's not going to change. Doesn't matter which side you come from. Because if you plug in, like if you come in 5.001 into here, I can tell you right now you're going to be really close to negative 20. You're either going to be like negative 19.999 or you're going to be negative 20.001 or something like that. But it's still going to be a fixed negative number that's not 0. Yeah?
What if it's like negative
What if it's what?
like a number that's really close to 0?
Where? Up here?
Yeah.
Well, when you say close to 0, it would have to be headed to 0. Like if it was headed to like, 1 over 1,000, that's still not 0. It would have to be headed to 0. And if it was headed to 0, right, if we had 0 over 0, then we'd be doing something completely different. All right, what's going to happen if I change this one? If we look at this problem, what happens if I come in from the other side? If I come from the other side of 5, we get what? Same answer, right? Because the top is still headed to negative 20, right? That doesn't change. The bottom is still headed to 0. And I don't care about which side because, again, I'm going to square that and it's going to become positive. So I know this is positive. I know that's a negative number. My answer is negative infinity. Which means that if I wanted to know the limit as x approaches 5, and I don't give you which side, right? This means you have to come in from both sides, right? I don't give you left or right side here. Your answer is what? Negative infinity. Because you knew from both sides you got the same answer. So that would be the rational function, basically both sides going like this. It's making sense? Yeah. Here's what I don't like seeing on tests. And I'm going to see it. Somebody in here is going to do it. They're just going to go graph the function. And then they're going to go look at the function. They're going to give me their answer. Right? And the only thing I can really say to you about that is that that sort of approach to something like this is just going to catch up to you at some point. Because you're just trying to find an easy way without having to understand how to do this. That will cost you at some point in your math life. It will. You'll have to pay for that. So especially if you have to go on Cal 2, differential equations, things like that. If you don't understand how numbers work with each other as things approach things, you don't understand those little nuances, then it's just going to be a struggle. Just be a struggle. All right, let's do this one. How about x approaches pi over, let's go pi, let's go pi from the right of cosine x plus 3 over sine x. All right, so I'm throwing some trig in here now for you, right? This is why I was saying we can't just focus on just rational functions. We have to be willing to open up our minds to other things. So let's just, again, first step for doing anything is, any limit is to just plug in, right? So I'm going to go in here and replace all my x's with pi's. So cosine of pi. Do you know what cosine of pi is? You should. -1. Okay, it's -1. But really, I mean, that actually doesn't matter. We know that cosine, the cosine function, when you graph it, is bounded between what two numbers? Negative 1 and 1, right? So if I add 3 to this, no matter what it is, if I add 3, do you agree that's got to be positive? Right? The worst case scenario is that this is negative 1. If I add 3, I'm still positive. Or it could be positive 1, but add 3, I'm still positive. So no matter what, my numerator is positive, right? I'm just going to put it up here. This is a fixed positive number. Does anyone have a question on that? You sure? What about sine? What's sine of pi? 0. Sine of pi is 0. So now what you need to figure out is whether or not you're approaching 0 from positives or negatives, right? So how are you going to do this? What do you think the best way to do this is? Trying to figure out what this is doing as I get close to pi from the right, right?
Like 1.1 pi.
You could start plugging in values that are bigger than pi, couldn't you? And get your calculator out? But that's working hard. Go ahead.
Maybe, I guess, for me, what I would do is visualize the unit circle.
Oh, you would do unit circle. Okay, you can do unit circle as well.
Yeah, and see after and before, like just after pi and just before pi, where the y value is.
So this is pi right here, right? We know right here that the point here is negative 1, 0. And sine is the y coordinate, right? So sine of pi is 0. That's from this unit circle. And you're saying if you go, what's your name again?
Andy?
Andy? Andy is saying that if you go a little bit past pi, right, to the right of pi, that means your angle is going to be a little bit further down like this. And now look at the, what coordinate there?
Negative.
The y coordinate, right? Because sine is the y coordinate. This coordinate, what can you tell me about it? Is it positive or negative? Negative, because you're down in the third quadrant, aren't you? So this is a negative number, so that means that this must be negative, right? That's one way to do it. I like that way. Another way is just to visualize the sine function itself, which is just, we know. We took pre-cal, right? That's the sine function. This is 2 pi. This is pi, right? What is the sine function doing as you approach pi from the right-hand side? Well, that means you're on this graph and you're approaching pi from the right. And all those points are, they're headed to 0, right? But they are below the x-axis, which means they're negative. You following? Yep. 2 different ways to do it. And then a third way would be if you do a number line, here's pi. You pick a number to the right of it, like 3.2, let's say, because pi is 3.1415. So you pick something to the right, and then you plug that in there, but you have to use your calculator. You have to make sure you're in radian mode. And to me, these 2 ways are much better. Okay, much better. Any questions on this? So what's the bottom? It's headed to 0, but it's negative. And so my answer is negative infinity, right? Positive divided by negative gives me negative. Okay. That's pretty much it. I mean, that's the way these are done. You just have to analyze what's going on. So let me kind of recap, all right? Recap what we've kind of said here for this first part here. We've said that if you take a limit, okay, doesn't matter what's going to what, okay, this doesn't matter. You got something here over something here, okay, this doesn't matter as well. If this goes to a fixed number over 0, then you have what possible answers?
Or, I guess
There's 3 possible things it can be, right? What are they? There's 3 possible answers. Infinity, negative infinity, or there is a possibility that it does not exist if you have to check from both sides, right? Right? That's it. That is the major takeaway from this. So we've learned in this class so far that if we have 0 over 0, we do algebra and a trick, right? But now if we see fixed over 0, we don't do algebra and a trick. We just try and analyze things to figure out if it's positive, negative, or does not exist. Two different approaches, right? Got it? Okay. Let me give you one. I'm just going to let you work on it together if you want. Oh, no. It's not bringing, okay, hold on. My other program didn't open up properly. Why is it not doing that? It's weird. Those aren't like exceptionally hard problems. They're just, see if you can do those two. I'll give you, what do you think you need for that? 6 minutes? 3 apiece? Those problems, I just pulled those problems directly off an exam that I've given in the past. You're not turning this in. I just want you to work it out. If you get an answer, check with your neighbor, see if you get the same thing. I've put the homework assignment that I'd like for you to do related to what we've been doing today here. That's so far. We still have more time, so we're going to get into some other stuff I might add to that. If you have a question, you raise your hand, let me know. Happy to come by and help. put that back up in a minute. Just want to look at something. Are you all getting it? Yeah? What's the answer to the first one? Negative infinity? Okay, because the numerator's headed to where? What's the numerator headed to on the first one? Negative 6, and then denominator's headed to 0. So you come into 2 from the right, so you pick a number like 2.01 or 2.1, plug it in, you can get a positive number on the bottom. So you have negative over positive, right? So negative infinity. Yes?
When solving these, do we have to carry our little limit with the x approaching 2 from the right whenever we're breaking it down?
No, because you're actually talking about what the behavior is as you're applying the limit. So it's okay to just get rid of it, yeah. These always cause students issues like, what am I showing? Like, what work am I showing, right? Negative, how about the second one? Negative 2 from the left. So the top's headed to negative 2, right? So top's negative. Bottom? Is it negative? So what test point did you use? Like negative 2.1 or something like that? And add that to 2 and you get a negative. Okay, so you get a negative over negative, which is positive. Okay, so negative infinity and positive infinity are the two answers. Okay, good. All right, let's move on. We still have some time. The next thing is just a nice little result of this. If you go back to college algebra, when you were talking about vertical asymptotes of functions, specifically rational functions, you were trying to figure out where the function goes up and down, where you have these vertical dotted lines. Now we have a different way to define a vertical asymptote. This says that we call the line x equals a, okay? The line x equals a, we will call that a vertical asymptote of some function. So imagine you have some function I'm going to draw here. Here's x equals a. I've got this dotted line here. This will be called a vertical asymptote of a function if any of the following things are true. The first condition says, I know it's kind of hard to see, if we're approaching a from the left, we go to infinity. So if this function comes in here and goes up like that, then this is a vertical asymptote. If it comes in and goes down like that, it's a vertical asymptote. Same thing on the other side. If it goes up or down, vertical asymptote. Any of those conditions, if any of them are met, then we call it a vertical asymptote. So let me show you something. What if I draw this? Here's the function, f. Does this function have a vertical asymptote at a?
Yes.
I've heard no and yes. Yes or no?
It approaches a from the left, yes. Yes.
Does it have a vertical asymptote? I'm not saying left or right. I'm just saying, does it have a vertical asymptote? Yes or no?
Yes.
Yes. Why? Based on what this is saying. This says that you will have a vertical asymptote at x equals a if any one of the following are true. You only need one condition to be met. So the fact that from the left I go to positive infinity means this is a vertical asymptote. The fact that it's defined at a and that it comes out here and it doesn't do infinity on this side has no impact on the fact that x equals a is still a vertical asymptote. That is different than the way you learn it in college algebra, because in college algebra you're only dealing with rational functions. So vertical asymptotes will never be defined in college algebra. And even in pre-cal, like the tangent function had vertical asymptotes, secant, cosecant. They were never defined at those asymptotes. But technically, to be a vertical asymptote, you could actually be defined there, according to this definition. Does So that's just a little side little note for us. We're ready to move on. So everything we've been doing here today, so far, everything we've been doing has been called infinite limits. Okay? That's what we've been, I should have put that up there earlier. Everything we've been doing are called infinite limits. All right? And because our answer is infinity or negative infinity or does not exist. So those are called infinite limits. Our limits are infinity. Positive or negative does not exist. Now we're going to transition to the second part of this section, which is called limits at infinity. And since this is a transition point of today, I wanted to show y'all something that's kind of cool. Some of you have probably seen this before. Oh, Jesus. That's not good enough. All right, that's better. All right. It's a little strip of paper, right? How many sides would you say that this paper has? How many sides would you say this has? 2 sides? I mean, you could argue that the edges are like sides, but let's just, for the sake of, I think what we could all agree on, let's just say this is 2 sides, okay? In fact, if I hold it like this, then you could say my index finger is on one side and my thumb is on the other, right? This is an example of a 2-sided surface. It's a surface with 2 sides, right? So what I'm going to do now is I'm going to take this and I'm going to twist it one time, and then I'm going to paste these edges together, and I create this shape. How many of y'all seen this before? You know what it's called? A Mobius strip, all right? What I'm holding here now is an example of a surface that has one side. There's only one side to this surface. So if you don't believe that, then all you have to do is start where your thumb is, follow the surface around, and as you do that, you're going to wind up where your finger is. And then you keep going around, and you'll be back where your thumb is. So my thumb and my index finger are actually on the same side of this surface. So it's a surface with one side. This is it kind of looks a little bit like the infinity symbol, right? Kind of. It's like if you